Let's talk about partial fractions, what they are and how to use them. So let's say we have two fractions, say 3 over x minus 1 plus 2 over x minus 2. How can we turn this into one fraction? We can simplify this simply by cross multiplying. So we'll do 3 times x minus 2 plus 2 times x minus 1, and then underneath that put the same x minus 1, x minus 2 from here. And then we can simplify further and distribute the 3 into the x minus 2. So we have 3x minus 6 plus 2x minus 2. And then for the denominator, we can use the FOIL method and multiply this out. So we have x squared minus 2x minus 1x plus 2, right? Okay. Now we can just combine terms up top. So we have 3x plus 2x, that's 5x. And then negative 6 minus 2, that's going to be negative 8. And then down here, combine like terms, x squared, negative 2x minus 1x, negative 3x plus 2. So we simplified what we had before, but how can we reverse this process? How can we get back to this? Well, that's where partial fractions come into play, and in this video I'll show you how to do it, and we'll go over an example or two. So in order to reverse the process we just did, we have to do something called partial fraction decomposition. First off, we need to factor the bottom. Factor this denominator out. So we're going to get the numerator up top, and then we're going to factor x negative 1 and negative 2. There we go. We factored the bottom. And now we need to write one partial fraction for each of the factors. So that's going to look like this. We have A, B, these are just placeholders for the top. And then we put one of the factors here and one of the factors on the other side. Now let's go ahead and cross multiply. We have to set it equal to the numerator. And we're going to have A times x minus 2 plus B times x minus 1. Now we need to find some constants, the constants being A and B. So we need to find roots. So the root here is going to be 2 because 2 minus 2 is 0, so that gives us a root. So we have 0 plus B 2 minus 1, which is 1, and then put our roots into this x here. We have 5 times 2 minus 8, which is 10 minus 8. So we have 2 equals 0 plus B1. Now we divide this 1 out. And so now we have 2 is equal to b. So we found what b is. Now let's find the other root so that we can find what a is equal to. So let's put b is equal to 2 up here so that we remember. So our root here is just going to be 1. We put a 1 in there, we get 1 minus 1, which is 0. That cancels all this out, so we have 0 plus a times 1 minus 2 is equal to 5 times 1 minus 8. So 5 times 1 is 5 minus 8. We get negative 3 is equal to a times negative 1 plus 0. Keep the 0 here just so that we don't lose our place and we stay more organized. Now let's divide this out. And we find that a is equal to positive 3. Negative 3 divided by negative 1 is just positive 3. So we have our answer. Let's substitute our values here. And we get 3 over x minus 1 plus b, which is 2 over x minus 2. Is that what we had before? I don't remember. I'm pretty sure it is. I'll look back. But we reversed the process, and we have our answer. So there you go. We reversed the process using partial fraction decomposition. Now, firstly, what we just did only works for proper rational expressions, where the degree of the top, being the exponent of the top, is less than the bottom. So a proper expression will look like this. X over x squared minus 1. So here, the degree of the top, the exponent of the top is just 1, and the exponent on the bottom is a 2. Therefore, it's a proper rational expression. An improper one, it's going to be reversed. Improper. So, yeah, like x squared over x minus 1. That's improper. If your expression, your fraction is improper, then you'd have to do polynomial long division to sort it out. But we're not going to hit on that in this video. In this video, we're just doing the partial fractions, which is a difficult enough kind of topic. I know it's a big pain when I got to do it in my classes. So here's a little tip. If you come across something like this, say you have x squared minus 4 times x squared plus 4 in your denominator. Here, this can be factored into x minus 2, x plus 2. While this one, you're going to get some complex numbers. That's not ideal. So what you're going to want to come up with is just x minus 2, x plus 2, 2. And then just leave it how it is, x squared plus 4. And that would be your denominator. You don't want to deal with complex numbers. Just try to avoid it. Sometimes you might come across a factor like this in your denominator. X minus 3 cubed. And for a situation like this, you're going to need a partial fraction for each exponent from 1 onward. So here's what that looks like. You're going to have a over x minus 3 plus b over x minus 3 squared plus c over x minus 3 cubed. And the same thing for if you have a quadratic as your denominator. So say you have 1 over x squared plus 3x plus 9 or whatever squared, all squared. So you're going to have partial fractions like this. So when you have a quadratic in your denominator, above that is going to look like this: b1x plus c1 over x squared plus 3x plus 9 plus b2x plus c2 over x squared plus 3x plus 9 squared. So now lastly, let's do one last example to kind of put everything together and use everything that I kind of went over. So this is going to be the example. Let's say we have x squared plus 15 over x plus 3 squared x squared plus 3. Now, because we have a factor with a exponent of 2, it's going to need two terms. And we have a quadratic also, so it's going to need a bx plus c. So we're going to have, say, a1 over x plus 3 plus a2 over x plus 3 squared plus bx plus c over x squared plus 3. Now we multiply through by x plus 3 squared and x squared plus 3, and we set it to our value up top. X squared plus 15 is equal to x plus 3 times x squared plus 3 times a1 plus x squared plus 3 times a2 plus x plus 3 squared times bx plus c, right? So there's going to be a 0 or a root at x is -3. So let's go ahead and put -3 in each of these to replace the x. So we have -3 squared plus 15 is equal to, well, this is 0, so that's going to turn everything in this term into a 0. So we can ignore that. 0 plus, now we have -3 squared plus 3 a2 plus, now see, this is going to be a 0 as well. 0 squared, still 0. Cross it out. Ignore that. 0. Okay. Now we have 9 plus 15 is equal to 9 plus 3 a2. 9, 10, 11, 12. Sometimes I still have to count. Sometimes. What is this? Oh, 24. 24 equals 12a2. Divide that out. And now we have our a2 value, a2. Oh, geez. a2 is equal to 2. Oh, man. Okay, so now that we know that a2 is 2, we can replace our a2 with 2. So we get x squared plus 15 is equal to... So here we have the same thing, but we replaced a2 with 2. Now let's go ahead and expand what we have. X cubed plus 3x plus 3x squared plus 9 a1 plus 2x squared plus 6 plus x cubed plus 6x squared plus 9x b plus x squared plus 6x plus 9c. So there we go, we expanded that all out. Now let's go ahead and organize it by our exponents. So we're going to get x squared plus 15 is equal to, let's do first our x cubed, a1 plus b plus x squared, 3a1 plus 6b plus c plus 2. And then we'll do the x to the first power times 3a1 plus 9b plus 6c, and then the rest, let's go down here, 9a1 plus 6 plus 9c. So there we go, we separated it and organized it by the powers of x. So now that we have that, let's go ahead and separate each of the powers and write them out as a bunch of linear equations. So we have the x cubed, we have our x squared, our x, and then our constants. So we have no x cubed here on this side. So 0 is equal to the x cubes on the other side. The only x cubes are a1 and b. So we have a 1x squared on this side, and then on this side we have 3a1 plus 6b plus c plus 2. And now for the x to the first power, nothing on this side, so 0. And then we have 3a1 plus 9b plus 6c. And then for our constants, we do in fact have a constant here on this side, and that constant is 15. And then we have 9a1 plus 6 plus 9c. All right, now let's go ahead and simplify these equations out. So we have 0 set to a1 plus b. Here we can subtract 2 from 1 to get rid of that. So 1 minus 2 is -1, set to 3a1 plus 6b plus c. And then we can keep this the same. 0 set to 3a1 plus 9b plus 6c. And then for this one, we can divide both sides out by 9. So we have 5/3 set to a1 plus 2/3 plus c. So now we go ahead and subtract 2/3 from both sides, and that gives us 1 set to a1 plus c. So now we got to try to find another value. Let's try and subtract this equation from this one up here, and then let's go ahead and get rid of this to make more room. We get -2 set to 2a1 plus 6b, and then the c got subtracted out. And now we can find b. Let's go ahead and subtract the first equation, but let's go ahead and multiply that first equation by 2. 2a1 plus 2b. -2 is equal to, that gets crossed out, 4b. Okay, now go ahead and divide 4 to get b by itself, and we see that b is equal to -1/2. Okay, so now that we have b being equal to -1/2, we can take this equation, 0 equals a1 plus -1/2. a1 is equal to +1/2. All right, there we go. And then now that we know that a1 is +1/2, we can figure out what c is. It's getting kind of messy. I hope you're following along, and I hope you're not lost. 1 is 1/2 plus c. Subtract 1/2 on both sides, and we can see that c is also equal to 1/2. And remember from before, we found that a2 was 2. So we have pretty much everything we need. We have a1, well, a1 is 1/2, b is -1/2, c is 1/2, and a2 is 2. Okay, now we can finally write out our partial fraction. So yeah, we have x squared plus 15 over x plus 3 squared, x squared plus 3 is equal to a1, which is 1/2. We can write it like this: 1/2 x plus 3 plus a2, which is 2, over x plus 3 squared plus bx, -1, 2, x plus c, which is 1/2. The 1/2's right there. X squared plus 3. Okay, and there we have it. That's our final answer. It's a lot of work. It's tedious, but sometimes it's necessary. And I hope I solidified your understanding of it, or at least gave you a nice example to kind of work off of. Thank you for watching.